In this video, we're going to look at an MYP e-assessment question. This was from November 2020 from the math exam, and this is the standard paper. So even though it's from the standard, it applies for both standard and extended. It's the same type of question. The investigation question at the end. So the question usually starts with something that will say, show them something. So in this question, they gave me a square where the sides are 3 units, and the question has asked me to show the perimeter of the square is 12. Well, we know with a square, all the sides are the same. We know with the perimeter, you add all the sides together, so that will give me 12. So you can either write 3 plus 3 plus 3 plus 3, or you can just times it by 4. So either one of them will get you the 1 mark out of 30. Okay, so that's the first question. If you're not sure on this, not too much of a big deal, but it does usually link in with the justification at the end. Okay, so we're going to move on. So the next thing will usually give you some sort of controller where it will let you see things happening to that original, in this case, square. So the first square, what they called stage 1, has a perimeter of 12. Stage 2 in this diagram tells you that the perimeter is 20, and so on, and it gives us the first 4 stages. So using this stage, it will say, can you complete the table? So in this question, you have to say what sort of pattern you have. So in this case, I can clearly see that it's going up in plus 8, plus 8, plus 8. So that means the pattern is increasing by 8. So that means our next one would be 44, and then we would have 52. So they're my next 2 values. The question will then go on to say, okay, describe 2 patterns that we noticed from the table. So it wants 2 different patterns that we noticed. So the first one we can say is we noticed that it increases by 8 each time. And then the second thing we can say is the type of sequence. So in this question, we know that it's an arithmetic sequence, okay? Because there's a couple of sequences. This one, it is increasing by a constant each time. So we say that it's an arithmetic sequence, and I wrote them on the next slide. Okay, so any of these, the last one, we can also notice that they're all even numbers. So that is something else that we notice. Okay, so once you've done this, the question, which I'm going to go down here, it will then say for 2 marks, write down the general rule. So the first thing we noticed was the difference was plus 8 each time. So that lets me know that my rule involves 8n. The question is talking about the perimeter, and it gives you that letter. So I'm going to write P equals, we can even put an N here, equals 8n, okay? However, if I look at this is not the 8 times table, because 8n would produce 8, 16, 24, and so on. So an easy thing to do is to just do the opposite of what the difference is, and that will get you what you need to actually do to the 8n. So now my rule is 8n plus 4. The next question then, that we'll go on to, it will say, can you verify your rule? So when it says verify, it wants you to substitute in what you predicted, so 5 and 6. So for this question, I am going to do both of them. So if I substitute in 5, 8 times 5 is 40, plus 4 is 44. So this verifies my rule, because it's what I predicted. If I do the same with 6, 8 times 6 plus 4, my answer is 52. And we go back to the table, there were the 2 answers there that I predicted. So here, you have to say that it matches your prediction and then hence your rule is verified. Okay, so for 3 marks, you're going to substitute 5 or 6 in, show that it matches your prediction, and then don't forget to say that it matches. Right, so then this leads on to the next part of the question, which is worth a big 20 marks, and it gives you all these bullet points together. Okay, so we're still talking about the same squares. So the perimeter of the squares, we know, is 8n plus 4. But now we're talking about the area of the squares, okay? So this says it wants us to investigate the relationship in the table with the area, okay? It wants us first to predict more values in the table. So the first thing I'm going to do is I want to see what is it going up by each time. So the first one is plus 16, the next one is plus 24, and then the next one is plus 32. So you can see in this question, it's not constant. However, the difference is increasing by 8 each time. So that means it is a quadratic sequence. And to get the next two terms, I need to add 40 and I need to add 48 to get 169. So that's the first thing I'm going to do. Right, the second thing I want to do, it says describe what is happening in this sequence. Well, I know that this is going to be a quadratic because the second difference is plus 8 each time. Okay, I'm going to show you at the end how to write this nicely and organised. So that one's the second one. The third one, it says write the general rule. Okay, so if I have 9, 25, 49, 81, I need to work out now what is the rule for this. Okay, so I'm going to write what we wrote before. So that's my difference. And it has a second difference of plus 8. So whatever your second difference is in a quadratic, we divide that by 2, and that lets us know what goes in front of the n squared. Okay, so 4n squared, what does that produce? You basically timed your square numbers by 4. So you've got, your first one is 1 times 4 is 4. 4 times 4 is 16. 9 times 4 is 36, and then 16 times 4 is 64. And I'm going to compare this with my actual sequence. So how do I go from 4 to 9? Well, we add 5. How do you go from 16 to 25? You add 9. How do you go from 36 to 49? Well, you add 13. And then the last one you are going to add is 17. So we can see here the difference isn't the same each time. However, it creates its own arithmetic sequence because it's plus 4, plus 4, plus 4. So that means the second difference is 4n. And to work out what the first what the constant is, it's going to be plus 1. So that means my general rule, I have to put them two things together. And in this question, it wants me to write it for the area. So my answer is A equals 4n squared plus 4n plus 1. So that is the general rule. Okay, now what we're going to do is we're going to test it and we're going to verify it. Okay, so when they ask you to test something, you're going to put the numbers in that they gave you. Okay, so this is for test. You just need to put one in. You can put a couple in to see if it works. So if I do this for test, okay, I am going to put in, let's say n is 2. So let's try that out. 4 times by 2 squared plus 4 times 2 and then plus 1. So that's going to be 16 plus 8 plus 1 is 25. And this matches the number in the table. So that works. Okay? And then you would have to write that. Then to verify, you have to put a number in that we predicted. Okay? So let's say we put 5 in. 4 times 5 squared plus 4 times 5 plus 1. This equals 121, and this matches what we predicted. Okay, so that's the test and the verify. The last thing we need to do is justify the rule. So what does justify mean? So justify is asking us, okay, can we use what we know in the question to get the actual same general rule for this sequence? Okay, so we go to the question and we say, well, it's talking about area in the second part and it's talking about the perimeter in the first part. Okay, How can we connect them together? Well, we know the perimeter has an equation of 8n plus 4, okay? And we know perimeter as all the sides added together, but we know area is length times width. So what I'm going to do is, I'm going to say, well, if 8n plus 4 is the perimeter, if I divide this by 4, it gets me the expression just for one of the sides of that square, okay? So that means the expression is 2n plus 1 and 2n plus 1, based on the sequence from the first part of the question. So then I'm going to say, well, if I use these as my sides, the area of the square is you just have to multiply them together. So this would give you, if you do double brackets and you multiply, you get 4n squared plus 2n plus 2n plus 1. And if you simplify it, you get the same equation that we got in the sequence. And that is justifying our rule. Okay? E-assessments, they are typed up. So what I would suggest you do is you write this on a piece of paper. You have over 30 minutes for this question if you have 72 seconds per mark. Write it on a piece of paper and it should take you no more than 10 minutes to type up. And when you're typing this up, just make sure you're taking your time. So when you're typing this up in the e-assessment, this is the perfect example of that last question. It should take no more than 8 minutes to type this up. So if you answered it on paper, it should take you maybe 10 minutes. Then you're going to type it up. That's 18 minutes it should take you for that question that you have over 20 minutes to do. Okay? And this is perfectly laid out in the sections of prediction, describe in words what is happening. So the quadratic, we know it's a quadratic because it increased by 8 each time. The general rule, so you show that you found the second difference. You knew that it was 4n squared, and then we got the rule. Test, you have to pick numbers less than 4 or the same as, so I chose 1 and 4, and then you have to write it matches the values in the table. When it's 5 and 6, this is when you verify. Again, this should match your prediction from the table, and then when you justify, you have to try and find that connection of how to get the rule from the question. So I used the perimeter. I divided the perimeter by 4 and got an expression for the sides of the square. And then if you times the sides of the squares together, you get that general rule.